friends, it's time for science, and we're going to talk about matter again, which I love. So matter, we've talked about three main things of matter, right? That matter, everything is made of matter, right? And it can be a solid, liquid, or gas, right? Matter has mass, has some sort of weight. Even gases do. If you fill up a balloon with helium, right, that makes it float up in the air. And the reason that it floats is because the helium has less mass than the air, that the carbon dioxide and oxygen that's in the air. So that's why it floats. Okay, that's why if you just blow up a balloon with carbon dioxide, it doesn't float, right? It just stays and drops to the ground. But helium is lighter, so it goes up. So even air, even gases have mass or weight. Also, matter takes up space, right? We did the experiments about that last time. So liquids take up space, solids take up space, and even gases take up space, right? That's why when you had the balloon that was flat, it was just flat. But then when you blew the air, the gas, into it, it takes up space. It made the balloon bigger. Okay, so every kind of matter, solid, liquid, and gas, have mass and take up space. Now, today I want to talk about matter can change. So matter can change. So what we're going to talk about today is sometimes matter. Now this paper would be a solid, right? It's a paper if it's here. It's a paper if I fold it sideways. It's a paper if I put it on the table. But I could change this paper. I can fold it to make it look different. I could even rip this paper, right? I could rip a solid. But remember, it's still a solid. It didn't change to a liquid or a gas, did it? Just because I ripped it? No. So you can change its form. If I have my shirt, right? It's a solid, it's a shirt no matter what. I can change it. I can wad it up. So now it looks different than it did a minute ago, right? I can put it out like this. Now I can fold it. Okay? And it looks different, but it's still a solid. Okay? So you can change things. If I poured water from a tall vase into water into a shorter cup, it's going to still stay a liquid, but it'll look a little different. However, sometimes you can change solids and liquids and gases into something different. So I want to think about a couple things with you, okay? So think about pancakes, okay? You ever helped your mom or dad make pancakes? If not, maybe you could try it and tell them it's a science experiment. So you have the pancake mix, the powder, and the powder you put in, at least that's how I make them. You put the powder in, and the powder is little teeny tiny solids. But then I add water to it, and the water is a liquid. And I stir it up, and those teeny tiny solids don't stay teeny tiny solids, do they? They become we call that batter, and it's a liquid. It would flow, it would move and change. But if I put them onto a hot pan and I let it sit for a little bit, this is really important. Heat can change it. And you have to flip it and all those kinds of things. But when you're done cooking it, is it still a liquid? No, it's a pancake. It's a solid. Right? So you can change things. So that started out as a solid. I added liquid to it. It became a liquid. And then it became a solid again because of the heat. So heat changes things. Really important. If you don't have heat, it changes things. If you do have too much heat, it changes things. So even, so if you have a wood and you have a campfire, right, you have the wood on there and you set fire to it, and pretty soon you get smoke coming in the air. You're changing it. The heat from the fire is changing it to a gas. And when you're done, you have little ashes. Now those would still be considered solids, but they're much different. They're tinier and much different. So you can change things. If you have water and you put it in a pot and you put it in some heat and you boil it, it starts to steam and it changes from a liquid to a gas. So it's super cool. So I have a few experiments that you're going to try. So this is the balloon bottle one where we created our own gas, and this is the one we did where we said that even the gas takes up space. But you can try this one at home if you want. This is solid pops. It's making your own popsicle where you take juice, which would be a liquid, and you take away the heat. So you put it in the freezer and you take away the heat and it becomes a solid, which would be the popsicle. This one is about eggs. And if you open an egg, it's kind of liquidy, right? If you break an egg, but then if you cook it, it becomes solid. So you can think about those things. So that tells you some there. And then the last one that's on this page, I'll tell you a couple more ideas. The last one that we have a paper for is root beer floats. So you have the ice cream, which would be a solid, and you have the liquid, which would be the root beer, but it also has some gas in it because you know what makes the root beer fuzzy and bubbly? Gas does, right? So you can put together your root beer float and then you can watch what happens to that ice cream when it's in your liquid. Does it stay a solid or does it change? Okay, so these are some ideas. There's also, you could do one, you could make pancakes and try that. You could make a fruit salad or a veggie salad. You could cut up the different solids, and see, do they change? Do they change to a different form, a solid, liquid, or gas, or do they stay a solid but just change the shape when you cut them up? So you can try that. You could also try making Kool-Aid or Crystal Light. So you have the tiny little mix or the sugar, and that has solids, but then you put it into some water with a liquid and see what happens to it. Does it stay solid in there or does it change? So there's a lot of different things you could try at home. So you need to ask a parent to help you or a grandparent and try at least 2 things, okay? Try at least 2 different experiments with matter and changing it, okay? So that is really fun. And then I have one experiment that I want to do with you with this too. So you will need to get your Dancing Colors page because we're going to do this together. All right, so you have your sheet here, and what I have here is just a pan with milk. So if you want to try this at home, you'll need milk, and it's best if you let the milk come to room temperature and have it a little bit warmer, not right cold out of the fridge. And it's also best if you use whole milk because whole milk has a little more fat in it, which makes it a little more dense and a little heavier as a liquid. Okay, so on the paper, it says, what colors did your teacher add to the lukewarm milk? So the only 2 colors I have at my house are green and yellow, so that's all we got here. So I'm going to add those to the milk. All right, do you see what's happening here? So there's the yellow, which kind of looks orangey. And the green. So on your paper, you want to write what colors? Yellow and green. Remember YELLOWGREEN. All right, so yellow and green. And then describe what happened. So what's happening to these? Are they mixing all in? Or are they staying on top? They're staying on top, so I'm going to put they, THEY, EY, remember, stayed on top of the milk. You can write that on your paper too. So they stayed on top of the milk. Now, remember when we talked about how matter has mass? We talked about density and we talked about sinking and floating. Well, the milk that I have has some fat in it and it makes it more dense. And that dense milk kind of stays together a little bit more so that the food coloring is a little lighter, so it floats on top basically. Okay, but here's what I'm going to do. So if you flip your paper over, it says, what does your teacher add to the milk and the colors? And this is what I'm going to add. All right, this is the kind I have at home. You can do with any kind if you want to try it at your house. It doesn't really matter what the brand is. So I'm going to add dish soap to the colors. Okay, dish soap. And then it says describe what happens, and then there's a spot for you to draw a picture. Now, the dish soap's job is to break up grease. In fact, it says strips grease guaranteed. And the grease or fat are the kind of the same thing. So it's going to make the fat layer on top dissolve a little. Okay, are we ready? Here comes the soap. Let's see what it's going to do. Whoa, look at that. Isn't that amazing? So the soap broke up that layer of fat on the top and it made the colors kind of dance together because they were all about the same density so they could mix together really well. So it looks pretty cool. So they call this the Dancing Colors Experiment. So you can try it at home if you want to, if you have the supplies to do it. All right, have fun.